the way we tell how many atoms we have for each atom, right, or each element, I would say, is that, again, we're looking at the little small subscripts next to and in front of each letter. So for carbon, right, we're doing pretty good. There's going to have 6. For hydrogen, it's going to have 5. Nitrogen's going to be 1. Why? Because it's blank, right? Just like in math, if there's no number in front of a variable in math, right, then it just means that there's one of that variable. So just like in chemistry, if the superscript is blank, that's just 1. And then finally for oxygen is 2. All right. Just, yeah, it's very easy, everyone. Just look at the subscript. That's all you have to do. So I think we're looking pretty good. I'm going to move forward because we have a lot to cover today. But if there's any questions later on about this review, just let me know. So as always, everyone, please don't share any personal information during class. Your participation will be required as always, and these sessions are still being recorded for learning purposes. All right, today is Wednesday, third lesson of this unit. Tomorrow is going to be a recording day, so don't forget about that. It looks like it's mainly being used to complete missing or failed work. So please be sure to use your time wisely as we are quickly approaching the end of the trimester. All right, and then we'll finally pick up back on Friday for one more lesson to end off the week. Okay, today's topic is going to be about something called the mole and molar mass. So that's going to be about this little cute guy over here. It's dealing with kind of how do we count something that is incredibly small like an atom? Well, it's very easy if we just take a whole bunch of them and put them into one unit called a mole. All right, but specifically, we will be identifying how many atoms are in a mole of an element. We will identify the molar mass of an element using the periodic table, and then finally calculating the molar mass of a compound with multiple elements altogether. So let's go ahead, use those links at the bottom of the chat to open up our notes, and raise your hands when you're ready to move on. All right, keep in mind that if neither of those links work, then you can always access your notes through your grades tab. All right, I see Jasmine is raising her hand, so thank you very much. Reminder, if you are on a phone, you can do that. Just send me like an emoji of someone, like a person raising their hand, or a smiley face or something like that.
Sorry. All right, everyone. This is a quick reminder that, again, I am going on maternity leave in less than 2 weeks. So I am having office hours every single day for the next 2 weeks at 2 p.m. to help with projects. Highly, highly recommend that you have your projects done before I leave because I don't know what your substitute situation is going to be. Taking a look here, we should have the Unit 1 food project, the Unit 2 element project, and the Unit 3 friendship project. All right. At this point, these will be the only projects for the trimester because we are going to replace the Unit 4 project with an exam just to make it easier to grade if you do end up with a sub. Perfect. Okay, no worries, Amazing. Thanks for letting me know. And don't forget that the final exam will still be a final exam. So again, between these projects and your exams, this will count towards 70% of your grade. So you need to make sure you're getting your projects and your exam done in order to pass the class and to make sure that you're just learning in general, right? This helps us make sure that you are learning what you are supposed to be learning. All right, let's go ahead and get started on our brainstorm.
So just a quick brainstorm to start things off, right? We have a lot of names in our daily lives that symbolize numbers of objects or people that we place into groups. So using the whiteboard, guys, place numbers under these questions to say what they mean. So we have how many eggs are in a dozen, how many years are in a decade, how many people are in a trio, and then how many people are in a duo. Right? There are some clues as to like the one for trio, right? Think of the word triangle or trifecta, right? How many years are in a decade? I believe a decagon has 10 sides. So if you love shapes and geometry, you might know that one. And then how many eggs are in a dozen, right? So a dozen, how many eggs usually come in a carton, right? That's how many a dozen is. There's also something called, I believe, a baker's dozen, but that's a little bit different. It has a different meaning to it, but we'll just stick with dozen for now. So awesome, yeah. So a duo is going to be 2, trio is going to be 3, decade is 10, and finally a dozen is 12. So great job on that, everyone. All right, let's move forward. This is going to be kind of like symbolically, at least, similar to what we're learning about moles.
Cool. All right. So much like the word dozen, which stands for 12, and this could be a dozen eggs, a dozen donuts, a dozen dogs, the same thing is true for a specific word in chemistry, and that word is the mole. Okay. And mole in chemistry stands for a certain amount. Specifically, it stands for 602 sextillion, 214 quintillion, 179 quadrillion of anything. That could be atoms, molecules, particles, dogs, cats, butterflies, etc. It's a really big number, right, Tara? Yeah, so here, usually we're using it in terms of really small things like atoms, molecules, and particles because a single atom is too tiny for us to see. However, if you have 602 sextillion of those atoms or molecules or particles, that is enough for you and I to actually see the that many things, okay? So just so you know though, obviously saying this huge number is really hard to say as well as really hard to write because we will be needing to use this number in calculations. So instead we rewrite this in a different form called scientific notation, which we'll talk about in just a few moments. But we can put a decimal after the first digit. So it becomes, instead of 602 sextillion, it can become 6.02. And then multiply it by 10 to the 23rd, which is a really big number. That gets us to this same number. Okay, so instead of doing this big number, we're going to rewrite it as this smaller number. I need everyone in the chat to go ahead and practice writing this right now because you are going to be asked for this number several times. So 6.02 times 10 to the 23rd, use a little caret to show the exponent. Everybody in the chat, practice that. Go, go, go. You will need to know that number. Thank you. By the end of this unit, you should probably have this number memorized because we're going to use it a lot. Thank you, Camila. Excellent. Rosa, Meza, Paul, Tara, Sophia. Yeah, this is also called Avogadro's number, so you'll hear this in many different forms. So you'll either hear the number 6.02 times 10 to the 23rd. You might hear it called Avogadro's number or called a mole. All of those things are kind of synonymous with each other. This is number 2. Go ahead and fill in the blank with the word number. Again, this can also be called Avogadro's number. 20 seconds, raise your hands for number 2. Again, this multiplying by 10 to an exponent is called scientific notation. Basically, it's just an easier way to write a really big number, or it could also write a really small number. But in this case, it's an easier way for us to write a really big number. Now, to prove that to ourselves, let's take a look at it. 6.02 times 10 to the 23rd. If you were to plug in the number 10 to the 23rd, so 10 to the 23rd in your calculator, it would end up being the number 1 followed by 23 zeros. So it'd be a really big number. It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 zeros. Okay, so a really, really big number. Again, you could prove that to yourself just by plugging it into a calculator. Smiley faces emojis in the chat if that makes sense. Smiley faces emojis in the chat if that makes sense. Great. Now then, if you take that big number and multiply it by that 6.02, you would end up with 602 sextillion. So 602, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, there we go. All right, so you would end up with our big number. So again, this is proving to us that this is just an easier way to write this really big number here. You could also do it in reverse. So again, all we need to do is put a decimal right after our first digit, which is that 6, and then take a look at how many times we move that decimal. This is kind of a trick once you have learned scientific notation. Again, you don't need to know a huge amount about this. Just know that if you ever see scientific notation, that this is what's happening. All right, so if I show that this moves 3 times, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, then I know that my exponent here would be 23. So again, this is just doing it in reverse, showing us that this is 6.02 times 10 to the 23. Jaden, there we go. All right. So this is going to be number 3. Go ahead and fill in the blank with the word scientific. Again, an easier way to write this huge number is to use scientific notation. Capitalization does not matter. Spelling does. 20 seconds. Here we go. Okay, so now let's go ahead and talk about molar mass. So we talked about what the mole is. Now we're going to go ahead and talk about something called molar mass, which, taking a look at that, you probably have an idea that it has something to do with the mole, okay, that we just talked about. So far we've learned about atomic mass. We know that atomic mass is found on the bottom of the periodic table square for an element. So in this case, the atomic mass of carbon is 12.011 AMUs. Now the problem is the atomic mass is literally the mass of a single atom. That's where it comes from. Atomic, atom, single atom, right? So a single atom, right, is our atomic mass in the units AMU. However, can you see a single atom? Tell me in the chat, yes or no. Can you see a single atom? No, it's way too tiny for us to see. So this is not a very useful amount. However, this number is actually the same exact number for the molar mass. And molar mass is for many atoms, specifically a mole of atoms, which is 6.02 times 10 to the 23rd atoms. That is going to be our molar mass. The new units for this will be grams per mole. All right, so right here you can see now it has different units, grams per mole. Now, 12 grams of carbon for a mole, or 6.02 times 10 to the 23rd atoms of carbon, that is an amount that we can actually see. That's a lot of atoms, right? 602 sextillion atoms of carbon equaling 12 grams of carbon. That's an actual amount that you can hold in your hand. So that's where this idea of molar mass comes into a really useful, it comes into being very useful, is because I know that if I have 12.011 grams of carbon, I know I have a mole of carbon, I know that that equals 6.02 times 10 to the 23rd atoms of carbon, or 602 sextillion atoms of carbon. And that is a useful measurement. Go ahead and give me a smiley face emoji in the chat if that's beginning to make sense. Again, molar mass is much more useful to you and me every day than atomic mass, because molar mass is the mass of a mole. It's an amount I can hold in my hand. Excellent. All right, this is going to be number 4. Fill in the blank with this new term molar for molar mass. 20 seconds. Capitalization does not matter. Spelling does. Okay, so let's go ahead and actually begin to practice this, because all that information is great, but it's going to make more sense the more that we actually practice it. On the whiteboard, what is the molar mass of sulfur? Again, I just told you that molar mass is the same number as atomic mass. So on our little square here, where is the mass? Is it the top number or the bottom number? Point for me up on the board. Go, go, go. Where do we find mass? Regardless of if it's atomic mass or molar mass, mass is always found where? Thank you. I see pink, I see green, I see purple, and I see some lines up there. I see yellow working hard, chartreuse working hard. Yes, thank you. We can see right here that our molar mass is this number at the bottom, and absolutely this is going to be 32.06. New units should be grams per mole, gram/mole of sulfur. Now, how many atoms are in 1 mole of sulfur? Well, it's the same number of atoms, or the same number that's always in 1 mole of anything. That's our Avogadro's number. That's our magic number. Scroll up to find that number and tell me in the chat, what is the magic number? What is that number that I asked you to practice typing out earlier? 1 mole is always what? 1 mole of anything, whether it's atoms, particles, dogs, cats, elephants, is always what number? Thank you, Tara. Thank you, Rosa. Thank you, Jazz. Yes, our magic number, Avogadro's number, is 6.02 times 10 to the 23rd. In this case, we're talking about atoms of sulfur, so my unit should be atoms of sulfur. Beautiful. Let's go ahead and try calcium then. Again, point for me on the board. Where is the molar mass of calcium? Take a look at its square and tell me, where do we find molar mass? Excellent. Thank you, yellow. Thank you, red, purple, blues. Lovely. Yes, it's that bottom number again. And so this is going to be 40.078 grams per mole of calcium. And again, how many atoms are in 1 mole of calcium? Well, how many atoms or anything is in 1 mole of anything? Again, yes, what is that number? Shane, start practicing how to type it. You will need to know how to type it, y'all. Excellent. Thank you, Adrian. Thank you, Tara. Thank you, Rosa. I see Camila. You can do it. Everyone else is doing it. I believe in you. You can type it out. Just copy what everyone else is typing out. Just copy what they have. You can do it. Thank you, Kyla. All right, there we go. Yeah, it's going to be 6.02 times 10 to the 23rd. In this case, atoms of calcium. All right, so still the same number, just this time we're talking about calcium. Now, I do want you to recognize that even though they have the same amount of atoms, one of these is heavier, right? You can see calcium weighs 40.078 grams, which is quite a bit of calcium, versus sulfur, which only weighs 32.06 grams. It only weighs about 32 grams. But that's okay. That doesn't break the rules or anything. Think about how like a dozen bowling balls, right? A dozen or 12 bowling balls is heavier than a dozen or 12 soccer balls, okay? So even though they have the same amounts, right, they're both a dozen or 12, right, they can still end up having more mass just because a single bowling ball has more mass. The same thing is true here, right? Even though they have the same amount of atoms, right, the overall mass of it ends up being a little bit more for calcium because each individual calcium weighs a little bit more. Smiley faces emojis in the chat if that's beginning to make sense. Again, you can still have the same identical number of atoms and weigh a little bit more if each of your atoms just weighs more in general, like you're a bowling ball. Great. All right. This is number 5. Make sure you select both correct answers. Molar mass is 32.06 grams per mole for sulfur. And atoms is always 6.02 times 10 to the 23rd. Same thing for calcium. Molar mass is 40.078. Again, a little bit heavier, but the atoms are still the same. It's just like a bowling ball, so it'll be a little bit heavier than sulfur. 30 seconds to answer number 5 and number 6, and raise your hands.
And use your color pointers from the whiteboard tools to point to the molar mass of xenon. All right, I'm the red one that's circling right here. I'm just showing you we're looking for the molar mass of xenon. All right, I see another red and a purple. Oh, now there's a green. Yeah, the green pointer there. Try to hover around that molar mass, everyone. All right, awesome. So the molar mass of xenon is going to be 131.29, typing this out, grams per mole. So now, how many atoms are in 1 mole of xenon? Can I have that in the chat, please? How many atoms are in 1 mole of xenon? It's that special number. All right, now can I have, so starting that process over again, now can I have the color pointers? Uh-oh. I don't know how that happened. Can I have the color pointers point to, for me, the molar mass of gold? Molar mass of gold. Yeah, exactly. It's going to be 100.97 grams per mole. All right, so that's actually significantly heavier than the molar mass for xenon, but how many atoms are in 1 mole of gold? Again, in the chat. So 1 mole of gold, how many atoms does it have? Exactly, so 6.02 times 10 caret 23rd atoms of gold. All right, heavier than xenon, we have the same amount of atoms per mole of each element. All right, so be sure to mark these answers down for number 7 and number 8 in your notes. All right, please be sure you're accurate with your typing so that you don't get any accidental wrong answers. All right, then raise your hands when you're ready to move on. I'll get out my timer yet again. All right, so this one's going to be a complete on your own, everyone. So go ahead and using your own resources, right? We're not pointing to anything, but try to locate the molar mass of strontium, which is going to be in this square. So don't be confused. It's still in this square, but you need to decide what number the molar mass is for strontium. And then how many atoms are in 1 mole of strontium, right? So remember that magic number that we keep talking about. All right, Avogadro's number.
Awesome. All right. So far we have learned about how to find the molar mass of a single element, but we can also find the molar mass of an entire compound. But that is going to be a little bit more complex just because we need to go ahead and actually add up some molar masses. So let's go ahead and take a look here and actually practice it. How many hydrogens do you see in water? Go ahead and tell me in the chat. How many hydrogens do you see in water? Look at that subscript. Yes, perfect, Tara. Thank you, Rosa. Thank you, Jazz. How many hydrogens are in water? Yep, there are 2. And how many oxygens are in water? Look at its subscript. It's a blank. Blanks mean what? Thank you, Jordan. Thank you, Jen. Yeah, blanks mean 1. Exactly, Paul, right there. So all we need to do then is take the molar masses of those individual elements, multiply them by how many times they occur in the compound, and then put it all together. So let's go ahead and take a look at the periodic table up here. I'm going to go ahead and share this with you once I find where my window went. Oops, here we go. Tools, share. And here we go. Let's take a look at hydrogen first. What is the molar mass of hydrogen? Go ahead and tell me in the chat. What is the molar mass of hydrogen? Again, think about where do we find mass? Is it the top number or the bottom number? Thank you, Tara. Thank you, Shane. Yes, Jen. Yes, Jordan. Excellent. Umeza. Perfect, Jazz. Yeah, it's going to be 1.008, that number at the bottom. What about for oxygen? What is the molar mass of oxygen? Where do we find mass on the periodic table? Thank you, Kyla. Excellent. There we go. Getting people in the chat. Beautiful. Yeah, again, looking at the number at the bottom, that's going to be 15.999. So let's go ahead and plug that back into our slides here and try this out. Okay, so up here we have that the molar mass of water is, of hydrogen is 1.008, and the molar mass of oxygen is 15.999. All right, so let's go ahead in your calculators. Please tell me, what do you get when you multiply 2 times 1.008? Because again, we don't just have 1 mole of hydrogen, we actually have 2. We said there are 2 hydrogens in water. So what is 2 times 1.008? Thank you, Adrian, Tara on top of it. Excellent, Matt. Excellent, Shane. Yes, Rosa, Umeza, perfect. Yeah, you should be getting 2.016, and we only have 1 oxygen, so 1 times 15.999 should still be what? That one's pretty easy to do. You don't even need a calculator for that. Yeah, it should still be 15.999. So now we know the molar mass of 2 hydrogens. We know the molar mass of 1 oxygen. Let's put it together to find the molar mass of hydrogens and water together, or hydrogens and oxygen together in water. So go ahead, add those all up and tell me, what do you get? 2.016 plus 15.999. Amazing. Seeing lots of great answers in the chat. Yes, yes, yes. We should be getting 18.015. Great. All right, so this is the molar mass of water. Again, 18 grams of water is an amount of water you can actually hold. This is about 2 tablespoons of water. All right, and so if you have this many grams of water, that means you also have 1 mole of water, or 6.02 times 10 to the 23rd molecules of water, right? So this is an actual amount that we can hold. This is why molar mass is so useful. First blank is going to be 18.015. Second blank, please write it out, gram/mole space H2O. All right, again, that 2 is just a normal 2 in your units. Please remember this last thing is an O, not a 0. Go ahead and raise your hands for number 10. All right, let's go ahead and try carbon dioxide. So how many carbons are in carbon dioxide? We've got a blank subscript. Blanks mean what? Blanks mean what? Yes, exactly. Blanks mean 1. And how many oxygens are in carbon dioxide? Take a look at the subscript after the O and tell me how many is that. Yep, there are 2 oxygens. Now we already know the molar mass of oxygen. We saw that earlier, 15.999. I'm not going to look that one up again. For carbon, we actually did this on a previous slide. What was the molar mass of carbon? What was the molar mass of carbon? Tell me in the chat. Yeah, 12.011. Awesome. So let's go ahead and plug that one in. 12.011. Perfect. All right. So now 1 times 12.011, we should still end up with 12.011. All right, so that one's really easy because we only have 1 carbon, so we only need 1 mole of carbon. What about for oxygen, though? We know the molar mass of a single oxygen is 15.999, but there are 2 of them, so we need to multiply it by 2. Tell me in the chat, what do we get? Molar mass of 2 oxygens. Thank you, Camila. Excellent, Paul, Tara, Rosa. Thank you, Jazz. Thank you, Sophia. Yeah, 31.998. All right, is the molar mass of 2 oxygens. Now we just need to put it all together. So we've got a single carbon, 2 oxygens, put it together to find carbon dioxide, and what do you get? Add them up, tell me in the chat, what is our final molar mass for carbon dioxide? Again, this is going to be the mass we need for 602 sextillion molecules of carbon dioxide. Yeah, 44.009 grams of CO2, right, would be a mole, grams per mole. Excellent. All right, so again, this is our first box, 44.009. Our second box, you should write out gram/mole space CO2. Nothing special with that number 2. Just write it out like that. And don't forget that this is an O, not a 0. That is an O. Raise your hands for number 11. 20 seconds. Here we go. All right, let's go ahead and take a look at ammonia. How many nitrogens are in ammonia? Blank subscript means, yes, exactly, means 1 nitrogen. And how many hydrogens are in ammonia? NH3, how many hydrogens? Beautiful. Yeah, there are 3. So I already plugged in the molar mass of nitrogen. There is only 1 mole of nitrogen, right? So 14.007 times 1 should still give me 14.007. How about for hydrogen, though? We know the molar mass of hydrogen is 1.008, but there are 3 of them in ammonia. So let's multiply it by 3 and tell me, what do you get in the chat? In the chat, what are we getting? Thank you, Shane. Thank you, Tara. Yeah, awesome. You should be getting 3.024. Now put it all together. What is our final answer? We know the molar mass of 1 nitrogen. We know the molar mass of 3 hydrogens. Put it all together to find NH3. What do we get for NH3? Excellent. Perfect. Yep. Be confident, Shane. That is correct. 17.031 grams per mole of NH3. Again, 17 grams, it is the amount of ammonia that you could hold, although I don't know why you would want to hold ammonia. But it's an amount of ammonia that you can actually hold. And again, if you're holding that much, that means that you have an entire mole of ammonia, an entire 6.02 times 10 to the 23rd atoms of ammonia. Here's our first blank. Second blank should be gram/mole. NH3. Again, don't do anything special with that number 3. Just fill that in for your units. Go ahead and raise your hands for number 12. 30 seconds, go, go, go. And then we're going to go ahead and wrap on up. Let us know in the chat if you got an A or B, because we want to celebrate you.
Element, we identified the molar mass, we learned what that meant, and we used both of those to calculate the molar mass of a. So great job today, guys. Go ahead and tell us how you feel. Do we feel awesome? Pretty good? All right. Just as words of encouragement, right? If you're able to learn and get past this lesson, then you should be pretty well set for success for the rest of the unit. All right, excellent, everyone. So if you haven't already, please go ahead and submit your notes. All right, if there are any questions, please just remain till the end of class. If not, go ahead and let yourselves out. Have a great day, everyone, and we'll see you back here on Friday.